What we're going to look at right now is what happens when we try to graph 1 over f of x, where f of x can be any graph. And if you want the 5-second version of this lesson, the 5-second of this version of this lesson says the only thing that happens is a point on your original graph, x comma y, changes to 1 over y. And with that, I could be done and say, we don't have to do any more of this lesson, because that's the simple idea. If you know a point on your original graph, f of x, all that changes is the y-coordinate becomes 1 over y. But even though that's really simple, there's some crazy things that happen as a result. So then you look later on, and there's like 6 steps to doing these that ends up happening as a result. But that's the simple idea that if you can graph what's on in the denominator, if you can graph f of x, all you have to do is change your y values to 1 over y. The x values stay the same. No problem. And you've done these graphs before. These were in grade 11, you did reciprocal graphs of lines and parabolas. When you did parabolas, that's when you got like the volcano, the speed bump, the pothole, the sad clown, Batman, whatever names you came up with them. Okay? So what happens? What are we going to do when we are asked to graph reciprocal functions? The first thing we're going to do is we're going to draw f of x first. Okay, so what's in bold is the big idea, and what is non-bolded is sort of an explanation. The next thing you're going to look at is wherever f of x has x-intercepts, you're going to draw asymptotes. Why? Because if my original function is equal to 0, if my y value is equal to 0, and I do 1 over y, I'll get 1 over 0, which is a non-permissible value. And where we have non-permissible values, you're going to get an asymptote. So what we're going to do is we're going to go through the steps rather quickly, and then we'll do some actual examples so you can see what does this actually look like. Step 3. You're going to draw a horizontal asymptote at y equals 0 if your original function goes up forever or down forever. In other words, if your original function's y values, if its range goes off to infinity or off to negative infinity, then you're going to draw an asymptote at y equals 0. The reason for that is if you had a really, really big y value, when you do 1 over a really, really big y value, it becomes 1 over a big value, which is really, really small. And that's the reasoning why it goes to 0. So again, maybe you want, later on, you'll want to think about these y reasons a little bit further and read through this to try to understand why these things are happening. But as your original values get very, very big, 1 over a very, very big value gets very, very close to 0. We are then going to plot certain points that are nice, okay? And this step here, sometimes we'll do it. We won't always do it. But if you have a point like 3, 1, when you do 3, 1 over 1, notice that it doesn't change. That also happens with negative 1. If you did 1 over negative 1, it's still negative 1. Those are called invariant points. So if you like highlighting new definitions, you can highlight invariant points because they don't change. Sometimes your invariant point is really easy to see. Sometimes it's not, so we don't always label it completely. Key points are where your original graph is a maximum or a minimum. So if you have a maximum in your original graph, when you do 1 over it, it will become a minimum. Yes?
If you put like where
Yeah, on the last step here.
Oh, wait. I guess it doesn't really make a difference. I just still have to do it. Okay, never mind.
Okay. For number 5, it's just, no, nothing really to hide. And number 6, we're going to finally draw our graph going towards the asymptotes. So these are just the steps. As far as the steps go, this is done for you on the next page. And steps 1, 2, 3, 4, 5, and 6 are done separately. To get your final graph, what we're going to do is do it all at once together right now. And I'm going to combine some of the steps so that it makes it even easier to remember. Okay? Step 1. We're going to draw f of x first. Step 2, I'll write it in red. On our page, step 2 was vertical asymptotes, and step 3 was horizontal asymptotes. If you just remember asymptotes and do both at the same time, it makes it easier to remember. Step 3, I would like you to do is just pick some nice points and do the draw where they're going to be. So I know that step 4 and 5 said invariant points and stuff like that. For ours, we'll just do some nice points. And then finally, we're going to graph. So we can combine all those 6 steps kind of shorter into 4 here. Wow. I'll put that off to the side. So here's our first example. It's f of x equals, well, we want to graph 1 over x squared minus 4. So the first thing we're going to do is graph f of x equals x squared minus 4. That's done right here on your graph. You know that that's a parabola that's been moved down 4 units. You have the point 0, negative 4. It would go over 1, up 1. So another point you would have is 1, comma, negative 3, and negative 1, comma, negative 3, negative 2, comma, 0, 2, comma, 0, 3, comma, 5, negative 3, comma, 5. Those are a bunch of nice points on our original graph. That's right, up 1 over 1, up 1 over 3, up 1 over 5. Or you could just quickly plug in the value, right? And use the table of values to find those points quite easily. Okay? Once you've drawn your original graph, you're going to, and we'll sketch it right here, right beside, draw our reciprocal graph on a separate graph. First of all, asymptotes. We do vertical asymptotes wherever our original function has x-intercepts. So I have an x-intercept at 2 and an x-intercept at negative 2. On all reciprocal graphs, you will draw vertical asymptotes wherever your x-intercepts, where you have x-intercepts on your original graph. Then, to decide, does our graph have a horizontal asymptote at y equals 0? Do your y values get very, very big? Do they go to positive infinity or to negative infinity? Yes. In our original graph, it's a parabola. It goes up forever. So then we will also add an asymptote at y equals 0. So in step 2, which I have in red there, asymptotes, do your vertical and horizontal asymptotes at the same time. Step 3, I just call it nice points. I have a bunch of nice points on my original graph. What's going to happen to 0, -4? It's going to become 0, 1 over -4. The only thing that changes is your y value becomes 1 over that. What's going to happen to 1, -3? 1, 1 over -3. And -1, 1 over -3. What's going to happen to 3, 5? It's going to become 3, 1 over 5. And we'll have -3, 1 over 5. And so now we did a bunch of nice points. Notice in this case we didn't do any invariant points because they weren't actually nice. There wasn't a really nice point where the y-coordinate was 1. Not easy enough to just say, I know what that point is. So it's okay not to do those points. And then once you've done all of your nice points, you can draw your graph. Your graph has to go towards the asymptotes. In this section, if I have the point -3, 1/5, in order to go to the asymptotes, it has to go up. There are no x-intercepts in a 1 over f of x graph, because the only time you would have an x-intercept is when your fraction is equal to 0 and your numerator is equal to 1. So when you have a point, like we have points here, you know that it has to go down towards your asymptotes. And here, and we get to start off with a sad clown face to remind you of how much you liked this last time. So you draw your original function first, then do your asymptotes, do a bunch of nice points, and draw your graph towards the asymptotes. And this happens every single time. Okay, so let's look at example 2. X squared plus 1. Here's our original graph. We're going to graph some nice points on it. We got 0, 1. We've got 1, 2. 2, 5. -1, 2. -2, 5. And then right beside it, we start with our asymptotes. Does it have any x-intercepts, the original graph? No. So no vertical asymptotes. Does it go off to positive infinity? Does it go up forever? Yes. So we will have a horizontal asymptote at y equals 0. Or if it goes to negative infinity. If your graph has an arrowhead on it that goes up forever or down forever, you'll draw the asymptote at y equals 0. Okay? No. Now we go to our points. What's going to happen to -2, 5? -2, 1 over 5. What's going to happen to -1, 2? -1, 1 over 2. What's going to happen to 0, 1? 0, 1 over 1, which stays 0, 1. 1, 2. And this one is your speed bump. Yeah, it's a little bit nicer to do more points. The example does 1 point because since this is the minimum, 0, 1 is the minimum of this graph, it becomes the maximum of the other graph. Yeah, these first two examples are reviews because we're doing parabolas. But what happens in grade 12 is it doesn't have to be a parabola on the bottom. Okay? You could have any function you were able to graph, and you could do the techniques for it. Does it make it any harder? Not really. Like you could have a log graph on the bottom. You could have a sine graph on the bottom. You could have, so we're going to do all of those, but we start off with these review ones that we did from before. So let's look at a new one. Let's put a square root on the bottom. Okay? Square root of x plus 4 is just your square root graph translated 4 to the left. There it's graphed for you with 3 nice points on it already. So we go to our reciprocal graph. Do we have any x-intercepts? Yes. We have an x-intercept at -4. So we have a vertical asymptote at -4. Does the graph go up forever or down forever? It goes up forever. So we will also have an asymptote at y equals 0. Ooh. Does that y equals 0 look darker than this x equals -4? It's like, I thought it was because my red pen hit the black pen and some of the black inks went onto the red and made it a little darker. This is like, this program is becoming so realistic because that could happen. Oh. Fancy. And so now we can take some points. What's going to happen to -3, 1? -3, 1 over 1. So that point would stay the same. What happens to 0, 2? 0, 1 over 2. So you can see that the key idea is that your y values just become 1 over y. The x values stay the same. Now, if you wanted to draw this towards the asymptotes, it would look like this. Ooh, I almost lost an E error on this one. I think they would give it to me, but I almost swoop too far away from my asymptote. Then
You're so unfair. Like, what if you just have shaky hands? Honestly, every single test this year.
okay.
Maybe I'm nervous for the exam.
Yeah, and what if they think it looks like a swoop, but you didn't think it did on your exams?
Could I like argue it? I've never seen any of my
That's-
exams that I've written.
You can look at your exam after
The provincial exam, they hold them. Some of them get sent off for remarking. So some people could not get a chance. But the other ones are returned to the school, but the problem is nothing's written on them as far as marking. There's like an extra bubble sheet that gets marked. So you have to cross-reference to find out where you lost marks.
Do you have to submit like expected marks?
Not for this course, no. So, given f of x below. So sometimes you're given the graph, which means step 1 is done for you. Even better. So then, right beside it, step 2, asymptotes. Do we have any x-intercepts? Yes. We have 3 of them. We have an x-intercept at -1. So we will have a vertical asymptote at -1. We have another x-intercept at 2. So we have a vertical asymptote at x equals 2. Get some black on this pen. Here we go. And then we have an x-intercept at 5. So we have x equals 5. Does this graph have an arrowhead on it showing that it goes up forever? Yes. So we also have an asymptote at y equals 0. Next, do we have some nice points? Yes, we do. What's going to happen to negative 5, negative 1? It's going to turn into negative 5, negative 1. What's going to happen to negative 2, negative 1? It's going to turn into negative 2, negative 1. What's going to happen to 0, 1? It's going to be 0, 1. What's going to happen to 4, negative 1? It's going to be 4, negative 1. Thank you. And what's going to happen to 6, 1?
Why did you do all ones? It's all the same.
It's all the same.
Alyssa, say goodbye to.
Yeah, I'm gonna
I guess
fail.
who's doing calculus next year?
This a straight line stays a straight line. But now the question is, should it go up or should it go down? It should go down. It doesn't have any x-intercepts. So this one has to go up and up. This one down and down. And there we have our final graph.